All right, we're solving decimal equations. And where is your point? Well, we need to make sure we put the decimal in the right spot. So we're going to go over our rules for decimal operations. All right, our first rule is with adding and subtracting numbers, and this is for any number. The like signs, you want to add them and keep the sign. And unlike signs, you want to subtract and keep the sign of the larger number. So oftentimes when folks start doing decimal equations, they'll forget these basic rules with their integers and forget that they also apply to decimals with positive and negatives. When we were adding and subtracting decimals, we want to line up the decimal and bring it straight down for our answer. So an example on that would be if we had 12.6 minus 3.1, we need to make sure that we line up those decimals. So 12.6, 3.1, it's going to look like that. And then we would just do normal subtraction and bring our decimal straight down for our answer. And then 6 minus 1 is 5, 12 minus 3 is 9. So it'd be 9.5. All right, we've talked about adding and subtracting decimals. Let's move on to multiplying and dividing. All right, so multiplying and dividing any numbers with negatives, we want to count the number of negatives. If it's an even number, it's going to be positive. If it's an odd number, it's going to be negative. So just a quick example there. If we had negative 3 times negative 1 times 4, we just count up the negatives. So we have 1, 2 negatives. 2 is an even number, so our answer is positive. So I just do 3 times 1 times 4, and I know it's a positive 12. And the same is going to hold true for our decimals when we multiply them. All right, so when we're multiplying decimals, the product, that means our answer of a multiplication problem, has the same amount of numbers behind the decimal as the numbers that are being multiplied. So for example, if we had 2.1 times 0.4, 4 times 1 is 4, 4 times 2 is 8, so I just ignore the decimals to begin with. I don't need to line them up. In this case they were though. And then I just count. So right here we have two numbers that are behind the decimal. See, the 1 and the 4 are behind the decimal. So I have two numbers there. So in my product, my answer, I need to have two numbers behind the decimal. So the decimal would have to be right here, and then the 8 and the 4 are behind it. So it would be 0.84. Now dividing is going to be a little different. We want to make sure that our outside number when we divide is a whole number. So the divisor, our number on the outside, must be a whole number. We're going to move the decimal that many places in the dividend, that's the number on the end, or the number on the inside, to make that true and bring the decimal straight up in the quotient. I'm going to underline end because dividend, it's the number on the end. That's just an easy way to remember which is which. Okay, so let's say we had, we had 21.16 divided by 0.6. Or 21 and 1600ths divided by 6/10. So we're going to write it forwards and say it backwards. So 21.16 is our dividend, and then 0.6 is our divisor. And our notes say that we need to make this number a whole number, not this one, the divisor. So I'm going to move it one spot to make it a whole number to the right, and then one spot to the right here. So effectively, you're just multiplying both of these by 10. Remember when you multiply by 10, it just moves the decimal? Kind of like the metric system, huh? So now I'm going to rewrite that. So it's 6 into 211.6. And then our notes say to bring that decimal straight up in our quotient. Our quotient is the answer to a division problem. So I'm going to bring that decimal straight up there. And now I can just do the operations. So 6 won't go into 2, but 6 will go into 21. So I'm going to write 3 times there above the 1. And 3 times 6 gives me 18. I subtract. I get 3. 21 minus 18 is 3. I bring down the 1. And 6 will go into 31 5 times. 5 times 6 is 30. Subtract and we get 1, and then bring down the 6. 6 will go into 16 twice. So then 2 times 6 gives us 12, and we get a remainder of 4. And I'm going to bring down a 0 now. And 6 will go into 40 6 times. We get 36, and we're going to keep getting 4 as a remainder. So that means our 6 is going to keep repeating. So it's 35.26 with a bar over the 6, because that 4 keeps being a remainder, so it's going to keep being 40. All right. All right, if you need to pause the video, go ahead, because we're going to move on to the steps on how to best solve decimal equations, now that we know the rules. And here we go. And here are our steps to solve decimal equations. All right, our first step is going to be use inverse opposite operations to both sides of the equation. So if you're adding, you need to subtract. If you're multiplying, you need to divide. All right, our second step is determine the sign of the answer and estimate by rounding. This is probably your most important step. This will keep you from making mistakes. And then our third step is going to be to use our rules. So we're going to perform our operation using our decimal rules that we just took notes on. All right, remember I said the second step was really important? Well, it's also equally important that you check your answer with that estimate. So you got to go back and make sure it makes sense. All right, and those are your 4 steps. So what we're going to do now is solve an example using each of these steps, and I'm going to label them so you can see it. Okay, let's say our example is 11.3 equals n over negative 6.8. All right, so the first thing is use inverse opposite operations. So I'm going to write my steps off to the side. I'm going to write what I do. So the first step is we're going to multiply by negative 6.8 because I want to solve for n. I'm dividing. The inverse is multiply. So multiply by negative 6.8. So now I'm actually going to do that. So times negative 6.8 times negative 6.8. These cancel. And n is just going to be the answer to that question. But the second step, I'm going to take a little extra time and just think about my sign of my answer. And I'm going to estimate by rounding. In other words, I'm going to ignore the decimals and just round these. So really, negative 6.8 rounds to negative 7. So on my second step, I'm going to treat it as negative 7 times, and what do you think that 11.3 would round to? How about we keep it 11? So it's negative 7 times 11 would be 77, but we have how many negatives? One negative. That's an odd number, so my answer is negative. So I've just determined that it's an odd number, so I have a negative answer, and I've determined that 6.8 is about 7 and 11.3 is about 11. So this is our estimate, negative 77. And on our fourth step, it better be close to that. Okay, third step, we're going to perform that operation. So I can do that off to the side if I want. I'm just going to do, I like to write the most digits on top when I multiply. So 11.38 times 6.8. So I put the 11.3 on top because it has more digits. And now 8 times 3 is 24, carry the 2. 8 times 1 is 8, plus the 2 is 10, carry the 1. 8 times 1 is 8, plus the 1 is 9. Now since I'm multiplying by tens, I'm going to put a 0 here for place value. Now we're on here, 6 times 3 gives us 18, put the 8, carry the 1. 6 times 1 is 6, plus the 1 is 7, and then 6 times 1 is 6. Now add them up, and we have 4, 8, 16, so carry it, and 7. Now remember your decimal rules when you multiply. You need to check and see how many numbers are behind the decimal up here. So I have 1, 2 numbers behind the decimal. So in my product, in my answer, I need to have 1, 2 numbers behind the decimal. So it's right after the 6. This would be 76.84. Now remember, on the second step we figured out the sign. We know it's negative. So I need to make sure that this is a negative 76.84. Don't forget that. Missing the sign misses the question. So third step we already did. That was our third step. I should label it third. Fourth step is check your answer with your estimate. Negative 76.84, really close to negative 77. So on our fourth step, we're just going to say negative 77 is about negative 76.84. Here's where you can catch, like if you put the decimal in the wrong spot. Let's say we had negative 77 and we got negative 7.684. We would know right away we had that decimal in the wrong spot. So really take that step seriously. You want to estimate first and then check your estimate. Is it reasonable? Yeah. So we're good. All right, we're going to do one more problem so you can see how these steps work. This one's going to be adding and subtracting. Let's do negative 6.4 equals W minus 3.17. And I'm going to write my steps off to the side. So first step, inverse operations. What am I doing with that W? I am subtracting the 3.17, right? So what I want to do is the inverse, which is adding. So my first step is add 3.17. And I'm going to show that right here. Whatever I do to one side, I do to the other. Those cancel. Second step, I want to estimate and I want to determine my sign. I'm going to look up here for a second. This is really a negative 6 because that 0.4, it's less than 5, so it keeps it the same. So negative 6, that rounds to 3. So I'm going to think of these as negative 6 plus 3. And what are my rules? These are unlike signs. So I subtract them and keep the sign of the larger number. So it would be negative 6 plus 3, and it's going to be a negative 3. So we've determined our sign, the larger number is negative, so our answer is negative. Now please be careful on these. Sometimes you'll have to reverse these when you subtract them because you want to subtract the smaller number from the bigger number. So keep in mind if that would have been written 3 minus 6, we would have done 6 minus 3 and then kept the sign of the 6. So sometimes you will have to switch this order is what I'm trying to say on when you actually subtract them and line them up. All right. Okay, we're on the third step. I'll write that over here. So we're going to do 6.4 minus 3.17. We line up the decimals when we do that. And that's really going to be a 0 here to hold place value. And I have to take away from here because I can't take 7 from 0. So it's 10 minus 7, which is 3. 3 minus 1 is 2. Bring the decimal straight down, and we have a 3. So I get 3.23 equals W. Now I can look for my fourth step. Do these match? Oh, they don't match. Well, it's a good thing I determined this sign earlier because that helps me catch my mistake. So don't forget, keep the sign of the larger number. The negative 6.4 is larger, so our sign is going to be negative. So that fourth step is really important that you catch it. And we'd say negative 3 is about negative 3.23. And luckily, I caught my mistake. All right, hopefully you're on your way now to solving decimal equations with some accuracy.